Okay, here we go with section 6.3 on parallel and perpendicular lines. We're going to be writing equations of lines that are parallel and perpendicular today. Now, just to remind you what parallel lines are, they are lines in the same plane that never cross. Okay, so they're going the same direction basically. And that's important because we're going to use that idea to get a feel for these lines. Now, what I want to start off by doing is to graph these two lines and look a little bit at them. So the first one starts at positive 5, goes up 2 and over 1. I'm going to do that one more time, give myself a better idea of what it does. And I will graph that line. Make sure to go from edge to edge. That's what Mr. Gall likes. Okay. The next one is, I'm going to zoom in on this and give us a little better look here. The next one is y equals 2x minus 4. So it starts at negative 4 and it goes up 2 and over 1, up 2 over 1. I could keep doing that forever and ever if I wanted to, but I'm going to run out of graph and probably run out of time before it's all said and done. So I just throw my ruler on there and draw that line. Okay. And I kind of missed the points a little bit. I was off a little bit. But no matter what, these two lines, if they were drawn correctly, these ones will probably cross eventually. But if you take a little bit more time drawing them, they're never going to cross. All right. They'll never intersect. For as long as, we talk about this coordinate plane goes on and on forever. It's not just the picture that you see. Okay, it goes on forever, and these two lines are never going to cross. So what do you notice is true about these two lines of their equations? Well, this number here is the slope, remember, and notice it's the same. Okay, so we're going to say that, and that's going to be kind of our rule, is that parallel lines have the same slope. So if I have two lines and I'm saying they're parallel, y equals m1x plus b1 and y equals m2x plus b2, then m1 equals m2. Just saying that their slopes are equal, and that's kind of what that rule says. But parallel lines have the same slope. Okay, so let's look at how to find, we're going to be asked to, for instance, find a line parallel to one of these lines through whatever point. So let's kind of come up with some steps to follow, you know me. So to find equations of parallel lines. So the first thing we're going to do is find the slope. Okay, so one is really just to use the same slope. So we'll use the same slope. Step 2 will be, well, we kind of have two things that we can do. So I'm going to say 2, and I'm going to say that this is option 1. So option 1 is to find the y-intercept using the point. So using the point. And basically what I mean there is solve for little b. So solve for that y-intercept using that slope-intercept form. Or another thing you could do is to use point-slope form and convert to slope-intercept. And let's look at what I mean by that. So you can use either way. I'm actually I'll do it both ways just to help us out. But I want to find the equation of a line parallel to these two lines. So find the equation parallel. Let's say that our line will be parallel to, let's just use y equals 2x plus 5. And it's going to be through the point through the point 7, 2. I don't think that's actually on any of these. No, 7, 2 is right here. Okay. Now, I want to find the equation of a line that's parallel to these two lines and goes through the point 7, 2. So my slope is going to be the same. It's going to be 2. All right. Now, I have two options here. Let's look at option 1. And let's just see what I mean. So we can go y equals 2x plus b, and I can plug these coordinates in. Let me zoom in on that a little bit, give you a little clearer look. So I can plug these 2 points in and see what I get. So my y is 2 times 7 plus b. And remember, I want to solve for b here. So I'll have 2 equals 14 plus b. And I will subtract 14. I'm going to run out of room here pretty quick. But we get negative 12 equals b, because those cancel out. Okay? And we've done that before. We did that when we were writing in slope-intercept form. It was the first section. So we could say that y equals 2x minus 12. All right? And that's not too much work. You know, you're just plugging in that point and figuring it out. Or let's check option 2 and see if we come up with the same thing. You know that since I'm bringing it up, it probably does give us the same thing. All right, again, I know my slope is 2, and I have a point. And I'm going to use point slope form and simplify it or convert it to slope-intercept form. So I know that point slope form goes y minus the y coordinate equals the slope x minus the x coordinate. And to convert that, remember I distribute, and then I'm going to move that negative 2 over. All right, well, let's start with distribute. So y minus 2 equals 2x. 2 times negative 7 is minus 14. And I'll add 2 to both sides. Cancel those out. So y equals 2x minus negative 14 plus 2 is minus 12. Notice I do get the same thing, and that's sweet. All right, whichever way you think is easier or you're more comfortable with, I want you to use that method. Okay, the biggest thing that I can always say is just use what works for you. As long as it's one of our options, you just pick whatever you want to do. All right, let's look at another example. And I didn't do myself any favors. Okay, we're going to have to find the equation of a line parallel to y equals 1/2 x plus 7 that goes through this point negative 3, 2. I'm going to use option 2 probably for most of this, but you know, maybe once in a while, maybe I'll do one of each here. We'll just make sure we stay honest here. But I really do like option 2. I feel like that's less steps. I'm always into finding shortcuts. So let's use option 2. I know my slope is 1/2. Okay, well, I need to use option 2, so I better not write y equals. I have y minus the y coordinate, so y minus 2 equals 1/2, parentheses x minus the x coordinate. So minus negative 3 would turn into a plus 3. All right. Now I'm just going to simplify. Bam, bam. So y minus 2 equals 1/2 x plus, I'm going to write that as 1 and 1/2. I'm going to go mix numbers on this thing. Okay? Because I know that I'm going to have to add 2 to both sides. I'm converting into slope-intercept form. Y equals 1/2 x. 1 plus 2 is 3. So plus 3 and 1/2. Not a really pretty equation, but notice with the slope-intercept form and the mixed numbers, you can tell what's going on a little bit better. And it didn't even take that much work, which is awesome. Go ahead and pause the video. I want you to do this problem. You can use either option 1 or option 2. I'm going to tell you right now that I'll use option 1. So pause it and go. Okay, welcome back. Hopefully you had a chance to get that. I'm going to use option, I think I said I was going to use option 2, but I'm going to use option 1, just solving for b. So I have y equals, use the same slope, 3x plus b, plug in my point of 2, 5. So the y-coordinate is 5 equals 3 times 2 plus b. And we have 3 times 2 is 6 plus b, subtract 6 from both sides, and we get -1 equals b. All right, and I'm going to rewrite that as y equals 3x minus 1. And I have done this problem the option 2 method, and we do get the same thing, so that's pretty cool. All right, let's move on. Next page. All right. Let's go ahead and we're going to do this kind of like we're starting over again a little bit, but not too bad. Perpendicular lines are lines that cross at a 90-degree or right angle. Okay, remember 90-degree angle or right angle, that's the same angle that the axes meet. Okay, that doesn't mean that one of these lines is going to be horizontal and one's going to be vertical. All right, but it just means that they're going to meet at that kind of an angle. So let's go ahead and graph these. The first one, y equals -2x plus 3. So I have plus 3, and I'm going down 2 and right 1. I'll do it one more time just for good measure. Yeah, down 2, right 1. Good. Okay. Graph my line. Graphing lines is so much fun when you have a ruler. When you don't have a ruler, it's kind of tough, but fold up a piece of paper and get straight lines. Okay. You like my little song? I hope so. All right, the next one is it starts at -5, and it goes up 1 and right 2. Up 1, right 2. Up 1, right 2. Bam, bam, bam. Graph the other line. You better have these graphed in your notes, otherwise Mr. Gall's not going to let you take the Mastery Challenge. All right. So when looking at these two lines, it looks like, yeah, they probably meet at the same angle that the axes meet, that right angle. You may have seen it pictured before as a little square angle there. Okay, yep, they meet at a right angle. We're good to go. So you're probably thinking that something must be up, all right, because we had a rule for parallel lines and we put it in this nifty little box. Well, we have a rule for perpendicular lines as well. So my question to you is, it has to be something with slopes. It's always with slope. What is the connection between -2 and 1/2? Well, the 2 is still there, but now it's a fraction. And instead of negative, now it's positive. So that's kind of the method that we're going to use to go between perpendicular lines. And we have a fancy name for that, and I'll also give you a symbol name too so that it helps out. And so we say that perpendicular lines, perpendicular, you don't know how to spell it, it's right over there. Okay, look right up there. You can't quite see it. It's right there. That's part of it. All right, perpendicular lines have opposite, meaning plus or minus, reciprocal, which means flip the fraction, slopes. So if I have two lines that are perpendicular, y equals m1x plus b1, and y equals m2x plus b2, I know that m1 equals the negative, flip it over, of m2. All right? And that's what that's how we're gonna do finding those perpendicular lines, is to take the slope, flip it over, and throw a negative in there. And basically throwing that negative in there just means change the sign. If it's plus, make it minus. If it's minus, make it plus. All right? And so we're going to follow the same rules. We're going to find the slope. And there's a little bit more work in finding the slope. And then you have two options. Either go solve for b or convert point slope form. Those are your two options for step 2. And then you should have it all good to go. I'm not going to throw another example in there. We're just going to go ahead and get right into this one. All right, so write the equation of a line perpendicular to 3x plus 5y equals 12. Oh boy, that's going to be fun. Passing through negative 10, 5. So the first thing I want to do, all right, this dang thing's written in standard form here. That makes life a little bit difficult, but I want to find the slope. I'm going to go into slope-intercept form. Remember, to change it into slope-intercept form, all I want to do is solve for y. Okay, and I'm going to do that right down here. So we have 3x plus 5y. I'm going to zoom in on that for a second. 3x plus 5y equals 12. So I'm going to subtract the 3x minus the 3x. Bam, bam, cancel. 5y equals negative 3x plus 12, and divide by 5 on both of these things. Okay, I know you're starting to freak out because we got, everything's a fraction, but in all actuality, we don't care about this 12 fifths. I hate to say it, but we really don't care about that guy. All right, all we care about is the slope. So my slope is negative 3 over 5. That's the slope of the original line. And I want to change that. Remember, I want to make it the opposite sign, so it's going to be positive, and flip the fraction. So we're going to have 5 over 3 this time, instead of negative 3 over 5. So we change the sign, and we flip the fraction. All right, now remember, we want to make the equation of the line that goes through negative 10, 5. So I'm going to go ahead and go with option 1 first. I'll solve for b. This could be a little bit difficult, but y equals 5/3 x plus b. And put the 5 in for y, and the 10 or negative 10 in for x, and solve for b. We're going to have some fractions to deal with. Oh, goody two-shoes. Hopefully you're getting a little bit better at fractions because we are mixing them in on a regular basis. Okay? So I want to add 50 thirds. All right? I'm going to add 50 thirds. So let's think about that. How many thirds are in 5? Well, it's 5 times 3. It would be 15 thirds plus 50 thirds. I'm going to stay in the improper fraction world on this one. 50 plus 15 is 65 thirds. That's still not going to reduce. We're still looking kind of ugly here, but I think we're going to be all right. Okay, we know that b, I'm going to rewrite it over here. B is that 65 thirds, so we're kind of done doing fraction operations. We just have to rewrite it. So we have y equals 5/3 x plus 65 thirds. Ugly problem, I know. That's why I choose to do those ones with you. And then I kind of throw more of an easy one at you. I want you to go ahead and pause the video, do this last problem, and we'll wrap this day up in a pretty little bow. All right, welcome back. Hopefully you realize the first step to do is to solve this equation for y, putting it in slope-intercept form so we knew what our slope was and we knew what our, well, we don't care about the y-intercept, remember, but we're going to go ahead and subtract 4x from both sides. Bam, bam, cancel. 2y equals negative 4x plus 10. Divide by 2 on everything. Those go away. Y equals negative 4 over 2 is negative 2. And 10 over 2, not that it matters, is 5. Okay, remember, all I care about is this slope right here. That's what I'm going to be using. So I take negative 2, and I flip it, and I make it the opposite sign. So it's positive, and that was 2 over 1, so I flip that, and it's going to be 1 over 2. All right, let's move over here and use that. So we have y equals, or sorry, I'm going to use, I'm going to use method 2. So I'm going to use the opposite of the y coordinate. So y plus 1 equals 1/2 x minus the x coordinate. So I'm still going to have fractions, it looks like, but I think we can handle it. So y plus 1 equals, I'm going to distribute. Converting this into slope-intercept form couldn't be easier. Well, it could, but then it wouldn't be fun. It wouldn't make you feel accomplished. I'll subtract 1 from both sides. Okay. When I'm subtracting 1, that's saying that I'll have 1/2 x, negative 1/2 minus 1. I'm going to use a mixed number here. 1 and 1/2. You could have wrote minus 3/2. That would have been correct also. If you went the decimal route, you would have 0.5x minus 1.5. Okay, those are the possibilities for your answer. I'm going to say that that's that or that. You don't need both. That's a waste of time. All right, good job today. We learned a little bit about parallel and perpendicular lines. Go ahead and get the practice problems done, application, mastery challenge, and we're moving through this unit. Have a good day. All right, so we've had number 4, Family Guy Math, number 3, Who Wants to Be a Millionaire, and for the next math fail, we have 2 10s for a 5. So somebody giving change to somebody, and they give 2 10s to break a 5. I hope you enjoy.
Hey, Lou, you gave me too much money. Huh? It's not going to cost all this. Have you got 2 10s for a 5? Just so happen to have it. That's it. Now,
That Elizabeth, I like her.
she's a regular scalp, that's why. That's a woman that knows her stuff. Now, let's see, the baggage room is where? The baggage room is around here somewhere. Lou, you know where it is?
Just a minute.
Right, what's wrong?
Just a minute. $15 went south. You gave me a lot of your fast talking.
Now, take it
Have you
easy.
got 2 pence for 5? And me, like I said, I'll give you 2 pence for 5 over there.
Wait a minute, are you accusing me of cheating?
Yeah, but you got 2 pence for 5.
Here's your 5. Give me back my 2 10s. Now get...
Much better.
Keep quiet.
I mean, but here's 2 pence. Give me a 5.
Huh?